You're nearsighted and you're near?
Yeah. But instead of being excited, I hear the
You're near hearing. You can only hear far away.
No, I can only hear low pitch.
Okay. Wow. It feels like there's a lot of people on, but God, I don't know what Jared. Morgan's calling you.
Who's Morgan?
What?
This is Morgan.
That's Morgan and that's Roy?
No, after that.
Oh, okay. Well, I met with Morgan's mom yesterday, and she was really worried about your trip that you're taking in a couple months. So, yeah. Okay, let's try this out. Yesterday we were doing dissociation and ionization equations. Dissociation equations, did they deal with ionic compounds or did they deal with acids? Luke, did they deal with ionic compounds? Like dissociation equations, did they deal with ionic compounds or acids? Ooh. Good guess, but no. They deal with ionic compounds. Dissociation equations are when the ions dissociate from each other, right? Ionization equations are when the acids make ions where there were no ions before. It's a small change. It's really nitpicky, but it's important for us to understand that. So when I add calcium chloride, when I add road salt to water, what's going to happen? I'm going to take my calcium chloride, and what's going to happen to it? Something. You should have all done these questions. Yes.
Was it even there?
Were you here yesterday? I don't know. Were you here yesterday?
John, are you here right now?
Yeah. Luke, you got your notes, buddy?
Yes.
Yeah, it's just taking you a couple minutes to take them
I
out.
already
Right?
did that, so.
I know, but
Yeah,
okay.
the water will land.
The water will break them apart, right? Yes. Okay. So when I add calcium chloride to water, I'm going to get calcium ions and chloride ions. Now, if you don't know what the charge is on a calcium ion, or if you don't know what the charge is on a chloride ion, what are you going to do about it? Just look it up, right? Don't be lazy. Don't just assume you know what it is. Just look it up. How many calcium ions are going to be made here? One. How many chloride ions are going to be made here? Two. Now, I need you to understand, sorry, my smartboard is kind of not working properly right now, so it's making it really difficult for me. Like if I write here, oh, that's not bad, but if I write, oh, okay, that's not bad. Whatever. Maybe I'm just complaining. So I'm going to make 2 chloride ions. Now, this chloride right here, is that a part of Hofbrinkel?
No. Yes.
Yes.
Yeah, it is a. Yeah, it is a.
Is this chloride right here a part of Hofbrinkel?
No.
No. I get it. I get it that Cl is a part of Hofbrinkel. I understand that you're mad at me that I'm changing the rules now, okay? But when I say Hofbrinkel, I mean an element all by itself, and it's just made of atoms. Are there atoms here? No. What is this? An ion. That's not part of Hofbrinkel. Chloride ions are not part of Hofbrinkel. I understand the difference is confusing, but you're just going to have to work with it. You're just going to have to practice it. Okay, let's try this. HF. So let's do the ionization for HF. I'm going to add HF, And when I add it to water, what happens? It's an acid, right? So what's going to break off of this acid? A hydrogen ion, a single hydrogen ion. What are we going to be left with? Fluoride. Do the slidey finger rule, right? HF turns into F minus when it gives off one hydrogen ion. Good. Okay. We tried to do ammonium hydrogen phosphate yesterday, right? I think that's the only example from these ones that we did. So what are the only two ions in ammonium hydrogen phosphate? Ammonium and hydrogen phosphate, right? So this thing, ammonium hydrogen phosphate, NH4, 2, HPO4 solid. When I put this thing in water, what are the two ions I'm going to make? What does an ammonium ion look like to you? NH4 positive, good. And then HPO4. What's the charge on an HPO4?
Negative
2 minus. And how many ammoniums are here? 2. And how many hydrogen phosphates are here? 1. Okay, perfect. And then the very last thing that I want to talk about here, let's see how much this is going to screw me up. Aluminum sulfate, so Al2SO4 3 solid. What's this going to split up into? What are the two ions in this ionic compound? Aluminium and sulfate. What are the charges on these ions? 3 plus. Where did you get that information from, Idris?
Data.
The data booklet. Good. Okay, and then where did you get the charge for the SO4? The table of polyatomic ions, right? In the data booklet. Okay, how many aluminums are going to break off of here? 2. 2. And how many sulfates are going to break off of here? 3. Perfect. Sorry, I apologize that it's getting really messy, but my smartboard is kind of just wonky right now, so I apologize. Compare dissociation and ionization equations by listing similarities and differences. Okay, we've got some ionization equations here, and we've got some dissociation equations here. Whoa, that's really hard for me to do. The top one, do we make ions? Yeah, but there were ions in there to begin with, right? The top one, it's just ions splitting apart. In a dissociation equation, it's just these two ions that were there to begin with. They're just splitting up from each other. But in HF, is this an ionic compound? Is HF ionic? Is it a metal and a non-metal?
No.
Is hydrogen a metal? No. Hydrogen is a gas. It is a non-metal. I get that it's on this side, but we talked about that yesterday. It's a non-metal. So there are no ions in here. HF does not, it's not ionic. There are no ions in this compound. What happens to it when we put it in water? It becomes ionized. So we take these atoms and they become ionized. Because of the attraction of the hydrogen to the water, a hydrogen ion gets ripped away by the water. That's what happens. So it's important for you to understand there are no ions in here to begin with, but it does make ions, and that's why it's an electrolyte. That's why acids are electrolytes. Okay, I wanna start talking about something called major entities in solution, and I want to be super clear about this. This is something that half of my Chemistry 30 students still struggle with. They never bothered to learn it, even despite their Chemistry 20 teacher saying, this is super important. It's not really going to affect you this year. I'm going to be totally honest with you. Major entities, we talk about it this year, and then we kind of just ignore it for the rest of the year. Okay? But in Chemistry 30, this concept comes back with a vengeance. It comes back, and we talk about it in every single unit in Chemistry 30 except for one. Okay? So I just need you to be aware of that. That my chemistry 30s right now are really super duper struggling with this idea of major entities. Okay, in order to predict the products of chemical reactions, we need to know what substances are in a solution, okay? So, like for example, when I dissolve, I'm sorry about that. When I dissolve sugar in water, does the sugar ionize? Is the sugar, the C12H22O11, do the C's break off from the H's, and do the O's break off from the C's, and do the... No. This isn't ionic. Is C12H22O11, is that an ionic compound? No, it's not made of ions. Is it an acid? No, it's not made, it's not an acid. It's not H something and something, COOH, okay? So all we have, when we put this thing in water, all we have is aqueous sugar. We just have aqueous sucrose. That's the only thing we're going to have. So if a reaction involves this, this is what we would write down in our reaction. When I take sodium chloride, sodium chloride and I add it to water, does it remain sodium chloride? Does the sodium ions and the chloride ions, are they still stuck together when we've dissolved them in water?
No.
No. And that's a huge difference. Now, all of a sudden, these chloride ions and these sodium ions, they can float around totally independently of each other. The sodiums can react with something, and the chlorines don't have to. The chlorines can react with something, and the sodiums don't have to. Do you see how that's different from sugar or sucrose? When sucrose reacts, if this is going to react, the C's, the H's, and the O's all have to react with something. But in here, when I put sodium chloride in water, the sodiums can do their own thing. The chlorides can do their own thing. And that's really important for us to identify. That's critically important. So, anyways, we'll keep moving on. Let's talk about this, but I want you to ignore something. Let's ignore the writing of the dissociation equation to see the major entities, okay? Let's ignore that. We're just going to focus on whether or not something is highly soluble or not, okay? Now, instead of aluminium hydroxide, let's pick something else. What negative ion do you want to choose? Aluminium what? Pick any negative ion in there at all. Bromide. Sure. Aluminium bromide. Aluminium bromide. Aluminium bromide. We're going to do aluminium bromide. Are you okay with that?
Yes.
Aluminium bromide. Let's take a look at aluminium bromide. What is the formula for aluminium bromide?
AlBr2.
Well, what's an aluminum ion?
Oh yeah, aluminum.
What's an aluminum ion?
Al.
Al3 plus, right? So this is 3 plus. And then what's a bromide ion? Br minus 1, right? So we're going to get 1 Al and 3 Brs. Now let's take this aluminum bromide, and I want you to tell me, is this thing going to be soluble or insoluble? Like, does it have high solubility or low solubility? There we go. Is it high or low? High. We got bromide here. And do you see aluminum in the list? Then it's most, right? So this is going to be really soluble. This is going to be soluble, and we're happy with this. So let's take a look. No, come on. What should I put for a state of matter here? Aqueous. What does that mean? If this ionic compound is soluble, what's going to happen to the ions? Is aluminum bromide going to stay as aluminum bromide stuck together? No. They're going to dissociate, right, Luke? And so the aluminum ions, are they now independent from the bromide ions? That's important for us to recognize. So this is going to be, let's just put like a colon here. We're listing the major entities here. Now we have aluminum ions. What else do we have here? We've got bromide ions as well. We're just listing the entities. That's all we're doing. We're listing them out. We're saying we got some of these and some of these. Absolutely, no problem. Let's do ammonium phosphate. What's the formula for ammonium phosphate? What's the charge on ammonium? +1. And what's the charge on phosphate? 3 minus. So how many ammoniums and how many phosphates do we need?
3.
Okay, so we need 3 ammoniums and we need 1 phosphate. What would I put for our major entities? Or sorry, what would I put for my state of matter? Is it aqueous or is it solid? Are we okay with the fact that it might be aqueous?
Yes.
Yeah? Okay. So what are we going to get? Is ammonium phosphate, when I put it in water, is the ammonium and the phosphate, are they stuck together in water? No, the ammonium ions are floating around independently of the phosphate ions. So let's list. We have ammonium ions and we have phosphate ions, PO4 3 minus. Let's do one more example, just because, like, I hopefully you have a little bit of room off to the side. Do you have a little bit of room off to the side somewhere? So let's pick something else. Let's pick silver chloride. What is the formula for silver chloride? Silver is Ag plus, and chloride is Cl minus. So when we put them together, we're going to get AgCl, just one of each. Now, is it going to be soluble, like aqueous, or is it going to be solid? I don't know, you tell me. It's solid, right, Morgan? Yeah, it's solid. See, all the people who aren't actually looking at their data booklet right now, they're not actually getting better at doing this. You know what I mean? The way you get better and the way you get faster at looking it up is by actually looking it up. Don't just listen to people look it up. Don't just listen to people say that they're looking it up, right? Actually look it up. Prove to me that AgCl is solid. So, is this thing, what that means is when I put this thing in water, is it mostly going to be soluble or insoluble? Insoluble. It is mostly not soluble. Yes, I agree. A tiny, 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 itty-bitty little amount of it will dissolve. But if I put a solid lump of silver chloride, I will never be able to get that solid silver chloride to be able to totally dissolve. Okay? There are some ways, but I won't be able to do it. So, this thing, what are the major entities when I put this thing in water? When I put silver chloride in water, does it stay as silver chloride or does it break up?
Stays the same.
It stays the same. So all of a sudden the major entity is just AgCl solid. Can the silver and the chloride, can they react independently of each other? No! Because the silver's stuck with the chloride, right? The silver is bonded to the chloride, and the water isn't strong enough to rip them apart from each other. So if they wanted to react, the silver and the chloride would have to do so together. Is that okay? Okay, all right. Let's take a look, and we have to define something for the very first time in our lives, okay? We have to identify something about acids and bases, whether or not they're strong or weak. So I want you to take out your data booklet, please, and I want you to turn to the acids and bases on page 8 and 9. Page 8 and 9. This is a conversation that never goes over very well, and that's because I think a lot of people have a really, really difficult time with what we're about to talk about. How many acids do you see on this list? A lot, okay? Do you see how some of these acids are like, there's almost like different sections to this table. Do you know what I mean? Do you see the two different sections to this table? There's a top quarter, and then there's like a bottom 3/4 to this table. Do you know what I mean? The top quarter, the top quarter is just these 6 things here. And then the bottom 3/4 is anything under something that we call the hydronium ion. You don't know what the hydronium ion is, and that's totally fine. These 6, I want to be very clear. We call these 6 things strong acids. They are what we call strong acids. And so if you wanted to, I got no problem with you doing this. Kind of highlighting them and saying that these are the strong acids. Now, what does that mean? These 6 are strong, then all of the rest of them are weak acids. So I want you to label those other ones. You just say, again, just say everything below here is a weak acid. Now, the thing that defines strong acids from weak acids, the thing that makes them different is, every time I add an acid into water, what pops off of the acid? A hydrogen ion, a single hydrogen ion. Now, the thing that defines strong acids is that every time I add one molecule, for every one molecule, you get one hydrogen pops off. It's a 1-to-1 ratio. Every single one of these acids ionizes. Every single one of them. So when I add 10 of these, I end up getting 10 hydrogen ions out of it. Okay? They all turn into hydrogen ions. But for the weak acids, that's not the case. The weak acids is something that we call an equilibrium. And so maybe for every 10 oxalic acids, one of them creates a hydrogen ion. Only 1 out of 10 will end up reacting. So let's think about this. Let's take hydrofluoric acid for a second. If I had a beaker and I added 10 hydrofluoric acids, you could draw this somewhere if you wanted to. It's up to you. It doesn't really matter. But I just want you to listen up. I want you to be off of your phone, off of your cell phone. That would be very handy. Thank you. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. Now remember, whenever I put one of these, this is like a beaker of water. As soon as I put one of these into water, ideally, what should pop off of here? One hydrogen ion should pop off of here, right? Now, the defining characteristic of weak acids is that maybe for every 10 of them, only one of them turns into H plus and F minus. So I'll circle them. Now, would you agree with this statement? The majority of the HFs did not ionize. Okay, so when I say the major entities, what's the major entity in water right now? What's the one that we can see is like way overpowering anything else right now? HF. Would you agree with that statement? Okay, so that's what that means. Strong acids, if I put a strong acid, if this was HCl, the reason why we're spending so much time on this is because I need you to understand this. As soon as I put one HCl into water, what happens to it? It immediately ionizes into H plus and Cl. And then I add another one, and it immediately turns into H plus and Cl minus. Do you know what I mean? So what's the major entity for strong acids? H plus, and what else do we have in here? Cl minus. Do you see the difference? What's the major entity here? HF. It's whatever weak acid we started with, right? What's the major entity in here, the two major entities? H plus and Cl minus. Oh, that's different. That's really different, and it's really important that we understand that, okay? So, the one thing that's most likely to react out of this is HF. The things that are most likely to react out of this is H plus and Cl minus. So we should kind of describe that. We should be able to write that down. Nitric acid. Look at nitric acid on your table and tell me, is it a strong acid or is it a weak acid? It's a strong acid. So which one of these is it? Is it the one on the right or the one on the left? Right. One on the right. So nitric acid does not exist when I put it in water. I need you to be very aware of that. If you bought a bottle that was labeled nitric acid, there would be no nitric acid in there. What would actually be in the bottle? Hydrogen ions and nitrate ions. That's what's in a bottle of nitric acid. It's not nitric acid, it's hydrogen ions and nitrate ions. So nitric acid is a strong acid. So the major entities in here is H plus and also NO3 minus. What about formic acid? Try and find formic acid on the table for me, please. It's a weak acid. So would you say, when I add formic acid into my water, because it's weak, would you say that all of them release a hydrogen ion? No. I would say most of them don't. Some of them do, right? It's still an acid, but most of them don't. So because it's a weak acid, are we going to say that we're going to have tons and tons and tons of H plus in that solution? No. What do we have lots of, though? Just whatever that weak acid is, right? Does that make sense? This is a super important concept that will absolutely come back and bite you in the butt if you don't get it. It's not going to bite you in the butt really necessarily this year, but next year it's really going to come back with a vengeance. Okay, hopefully we're okay with that. Okay, molecular substances. You know how we've got ionic compounds, we've got acids, we've got molecular compounds, right? Molecular compounds that are not acids, I need you to understand, there's no way for you to be able to tell. Right now, you've got absolutely no way of telling if something is super soluble or if it's insoluble, okay? The only way is if I kind of tell you. So I will say, like in a question, I will say something, 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 then solid, right? Or I'll say something, 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 then liquid, or something, 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 then gas, okay? I need you to understand that there's no way to be able to tell straight out of the gate. One really common one is methanol, and another really common one is ethanol. So if I were you, I would memorize that those can be dissolved in water. And also like glucose and sucrose, right? Those are sugars, they can be dissolved in water. So what happens, if I have methanol and I try to dissolve methanol in water, it will dissolve. So instead of saying CH3OH liquid, what should I say if it's dissolved in water? I should say aqueous. But is this ionic? Are there any ions in here? Ooh, we got to get used to that question. How many times have I asked you that question so far? How many times have I asked you, is this thing referring to anything? Is this thing ionic? Yeah, 1 billion times already. And I'm going to ask it 1 billion times more. Get used to it. Is this thing ionic? Does it begin with a metal or ammonium? No. So it's not going to break up. Is this thing an acid?
Yes.
Yes.
There's OH in the end.
It's got OH in the end, right? So it's an acid, right?
Base.
No.
Base.
No. What do acids begin with?
Metal.
H. Or what do they end with? COOH. Does this end in COOH? No. Is this a base?
Yes. I don't know.
Bases have to be, I know. But bases have to be ionic hydroxides, right? Is this ionic? No, then it's not a base. Woo! Are we going to get used to that by the end of the semester? Hopefully is that's if you have any homework. I mean, you're going to have homework maybe, but if you have any homework over the weekend, you got to understand this idea. Okay. And then the last thing we need in order to be able to understand this is elements. Elements are not usually soluble unless I tell you that they are. Okay? And I can't think of a single element that is soluble in water. So write the element with its usual state of matter beside it. Carbon. What's carbon's state of matter usually at room temperature?
Solid.
I don't know. You tell me. What is it?
Like whatever they do.
Whatever that thing says. What does it say? It's a non-metallic solid, right?
Yes.
When I add carbon to water, have you ever added like pencil lead to water? Do you think it'll dissolve? No, it's not.
Will it taste good?
Yeah, no, it's not going to taste
Oh,
good.
that's why I did my tattoo.
Oxygen. When's the last time you bubbled air through water? Did the bubble disappear halfway up through the water? No, it didn't dissolve, right? What's oxygen going to be?
Yes.
Gas. When I add oxygen to water, it'll still be a gas. Most of it will still be a gas. A tiny little bit will dissolve, but most of it will be a gas. And then sulfur. What's sulfur going to be at room temperature?
Solid.
Solid. Okay, good. Okay. Woo! So, this table identifies, and man, when you look at this table, you're like, holy crap. That's a lot of information. But let's just calm down, take a huge deep breath, and then breathe it out. And it'll be okay. Calm your heart rate. Ionic compounds can either have high or low solubility, right? If ionic compounds have high solubility, what happens? They separate. So when I put salt into water, what are all of the major entities in that solution? When sodium chloride gets dissolved in water, does it all? No, it splits up into sodium ions, chloride ions, and then what else do you have in that mixture as well? What else do you have in that mixture? Water. Water can react with stuff. Okay? So we will, what do you notice is at the end of every single one of these lists? Because we tried to dissolve them in water, so water's there. Okay, a low solubility compound. If this thing won't dissolve, are we going to write it as aqueous and split it up? No, we're just going to keep it as a solid, right? Bases. Bases are high solubility. They're hydroxides, okay? Just don't worry about the low solubility garbage there. Molecular substances. Sometimes they're soluble, sometimes they're not. Remember, sugars are soluble, and then methanol and ethanol. And past that, I don't care that you remember them, okay? Sugars are soluble, so glucose and sucrose, and then methanol and ethanol, they're always soluble. If it's low solubility, you just keep it. When's the last time somebody saw gasoline mixed with water or oil mixed with water? Did the oil mix with the water really, really, really well? No. So if you took vegetable oil and you mixed it with water, would you be able to see liquid vegetable oil on top of liquid water? So that mixture is liquid vegetable oil with liquid water, right? Those are the major entities that we have present. Does that make sense? When I have sugar, when you mix sugar with water, can you see the sugar anymore? No, you can't. If it's high purity sugar, it'll just totally dissolve and you won't be able to see it at all. So it'll be aqueous sugar and then just water. Strong acids. Ugh. Oh man, sorry. This is really bugging me. Strong acids. What do strong acids do all the time for every single one of them?
They always separate.
They always break up. They always ionize, right? So when I add hydrochloric acid, is it really hydrochloric acid?
Nope.
No, it's hydrogen ions and chloride ions, right? And then always water, there's always water present when you dissolve things in water. If it's a weak acid, right, it doesn't ionize. It stays as whatever weak acid it is. And then elements are always low solubility. Just whatever state of matter they are, then that's their state of matter. I want you to do some practice problems for me, please and thank you. Is this a lot? Sure looks like it. It's not that much.
2, 3.
Okay? Do you want to do some together?
Yeah.
Yes.
Okay, let's do some together. My first question, what question, how many times, Abby, I know you're looking at the clock and you're like, oh my God, when will chemistry end, okay? But what's the question I've asked you more than any other question in this semester?
Is that ionic?
Is it ionic? Let's look at the first thing. Is it even a compound?
No.
No. So if I take zinc, let's say I take a solid chunk of zinc, right? I don't have a solid chunk of zinc, but I have a solid chunk of aluminum, okay? Watch me do this. I'm going to do a magic trick. When I take this solid chunk of aluminum, assume that it's zinc, okay? And I add it to the beaker. The beaker contains water. What's going to happen?
Fine.
Oh, wait. What happened? What are our major entities in this mixture now? What are the two things we have? We have water and zinc, aluminum, but we have zinc, solid zinc. Did it turn into zinc ions? Or are they still atoms? Are they still metallic atoms in here? Still metallic atoms, right? So zinc, when I add zinc to water, I get zinc and water. Does that make sense? That says Zn solid and water. It's just that my smartboard doesn't agree with me today, so my writing is worse than it typically is. Sodium bromide. Which one of these is it? Is it an ionic, a base, a molecular, a strong acid, a weak acid, or an element?
Ionic.
It's an ionic compound. Are we okay with sodium bromide being ionic? It's a metal, non-metal. Okay. So now what could we do? Is it high solubility or is it low solubility? I heard an audible gasp from the audience. Ugh. Just don't be afraid to use your table. Get used to using your table. It's aqueous, right? So, the sodium bromide, we're not even going to write down the original formula for it, okay? Is the sodium bromide, because it's high solubility, is it going to stick together?
No.
No. It's going to split up into sodium ions and bromide ions. So what are the things we're going to have? Na positive, right? Dissolved in water. What else are we going to have in our mixture? Bromide ions, Br minus ions. And then are we going to have water in our water?
Yes.
Hell yeah, we're going to have water in our water. The reason why we get you to include water is because water is still available to react with stuff in water. Okay? So we need to write it down because it could react with things. Oxygen, is it a compound or an element? It's an element. What is the formula for oxygen? O2. It's not an ion, it's an oxygen atom, or it's a group of oxygen atoms. So it's going to stay as O2. Are elements really, really highly soluble? Do they disappear in water when you add elements into water? No. So what state of matter will it be? So if I'm bubbling oxygen through water, does it make sense that the bubbles, they're just going to kind of float to the top? And then we're still going to be left with water, right? Yeah. So that's our mixture. We have oxygen bubbles and we've got water in our oxygen bubble water mixture. So far, has anything been really confusing to you? Does anything not make sense? Or is it that you have a hard time figuring out where to begin?
Maybe.
Is that what it is? You have a hard time figuring out where to begin?
We should write the steps.
Yes.
What's the first question you need to ask yourself?
Is it ionic?
Is it an ionic? No, if it's not ionic, can it be a base? It can't be a base if it's not ionic. So you have to ask yourself, is it ionic? Is it molecular? Is it an acid? Or is it an element? Those are the four things we've been talking about since the beginning of the semester. Ionic, molecular, acid, element. Ionic, molecular, acid, element. Ionic, molecular, acid, element. And then from there, you just go, you just move on. Do you want to do more together?
Yes.
Let's do nitric acid. We already did it, but let's do nitric acid. Is it an acid?
Yes.
Then look at your table of acids and bases. No. Is it a strong acid or a weak acid? So do strong acids,
Separate.
do they separate?
Yes.
Yeah, totally. Would you agree that strong acids, the reason why we define them as strong acids is because the hydrogen pops off really easily. So what are we going to have here?
H plus.
You're going to have an H plus ion, and what else? Let's use the slidey finger rule, right? Nitric acid, what does it turn into? An H plus pops off and it turns into NO3 minus. All right, so we're going to have NO3 minus. NO3 minus. And what else do we have dissolved in our water? Water. Are you kind of getting the hang of this?
Yeah.
Kind of. Do you want to keep doing more?
Yes.
Nope.
Yes. Ali's looking at her phone. She's thinking, when will this class end? Holy guacamole. Somebody save me from this torture. Yeah. Okay, calcium phosphate. What's the first question you have to ask yourself? Is it ionic?
Yes.
Yes. Now you have to ask yourself, does that ionic compound, is it going to split up or is it not going to split up? Does it have a high or low solubility? The more you have a smile on your face right now, the easier this will be to do. Trust me. You got to do it either way. You might as well have a smile on your face. You have to do it.
It's low.
It's low soluble. It's not really soluble, is it? So when calcium phosphate, when I put it in, if it's got low solubility, is it going to split up?
No.
No, it's going to stay together. So now you have to write the formula for calcium phosphate. And this is where people get really screwed up. What is the formula for calcium phosphate?
Ca3PO4.
Ooh. Calcium is what? 2 plus. And phosphate is what? 3 minus. So how many calciums and how many phosphates?
2 calcium.
We need 2 calciums, Ca2, and 3 phosphates, PO4, 3 in brackets. And it's going to be a solid, right? It didn't want to dissolve, so we won't let it dissolve. So it's a solid. What else do we have? H2O. Is this practice helping? Are you happy you're here today?
No.
Would it be easier learning this now with me or later without me?
Now with you.
Now with me. As much as this is painful, it's easier to learn this right here, right now in class. Feel sorry for all the poor schmucks who are not here right now. Idris.
I think you're supposed to have Ca3.
Yeah, I am.
Yeah.
Thanks,
Yes.
man.
You're welcome.
Somebody's looking out for me. It should be Ca3PO4 2. That's what I get for not having my brain in game. What's the first question you have to ask yourself? Is methanol ionic? No. If it's not ionic, can it be a base? No. So methanol, what's the formula for methanol? CH3OH. It'll be faster if you memorized it, right? But looking it up is fine. Looking it up is fine. So CH3OH, is that one of our things that is maybe dissolvable in alcohol or in water? Yeah. I'll give you a hint. I'm going to regret saying this. How many of you have experience with alcohol? Nobody puts up their hand. How many of you have any in any way, shape, or form? And the camera's facing at me. It's not facing at you right now. How many of you have experience with alcohol?
I've seen it.
Yeah, you've seen it. That's experience, right? You've seen it. Okay. So when you saw the bottle of alcohol, okay, did you see two totally different? Was it all separated? There was like a this layer and that layer, or was it mixed together pretty well? That means anything that ends in an "all," methanol, ethanol, alcohol, is soluble in water. Are we okay with that? Yes, alcohols are soluble in water. Methanol and ethanol. I know that none of you have experience with alcohol, other than seeing it, of course, right? But that's just a way to remember it. That's just a way to understand. So methanol, can you dissolve it in water?
Yeah.
It's an alcohol. It can be dissolved in water. So let's write its formula. Is it going to split up? Is it an ionic compound? No. Is it an acid, a strong acid? Those are the only two things that split up, right? So if it's not a strong acid and it's not a high solubility ionic compound, it cannot split up. So it stays together, but it's still aqueous. Stays together, but it still dissolves in water. And what else do you have in your alcohol mixture? Yeah, believe it or not, unless you're drinking pure, and I won't say it, but unless you're drinking pure alcohol, there's water in there. Do you feel confident doing this? I want you to do the next 7 for me, please. And I'm going to walk around, and you whip a pencil at me if you need me to, if you need my attention. You go. No. That's just different. That's showing you what happens when I put a tiny amount of that thing into water. If you put a tiny amount, it will split up, right?
Okay.
Yeah. Doesn't matter if it's high solubility or low solubility. When I put a tiny amount, always a little bit will split. Yeah. Yeah. Yep. Yeah. You can buy a bottle of nitric acid. It'll say nitric acid, but what's actually in nitric acid? Okay, so HNO3. HNO3 results from when I dissolve nitrogen dioxide into water. Okay, so this is way too much chemistry, but you asked, okay? Yeah. So when I dissolve the gas nitrogen dioxide into water, NO2 add H2O plus NO2, you basically get HNO3. Now, the moment HNO3 gets surrounded by water, which is all the time, okay? But the moment it gets surrounded by water, a hydrogen immediately gets written. We call it nitric acid.
It's a solid.
And we write down
I know
HNO3.
that, but where?
But what
It's
you
not
have to understand is what's
How do you know?
actually in
It's a
that
solid.
bottle
How do you
of
know?
nitric acid. There is
I
no
saw that
HNO3
already.
to be had anywhere.
But how do you know it's a solid?
Okay? The nitric acid, the moment it hits another water molecule,
Yeah, but that's not the same thing.
nitrate,
Chromium is still
hydrogen.
How is it that it's solid?
That's you're buying nitrate
So how do you
ions. We call it nitric acid because nitric acid is the mixture of hydrogen and oxygen.
But it's still
It's still an acid because what makes an acid an acid?
It's not.
Hydrogen.
Put oxygen.
It's the presence of hydrogen ions that makes it an
so they're all together.
acid. Yeah, it's all together in the bottle, but this nitrate ion is floating around, bouncing off the things, and this hydrogen ion is totally independent from that nitrogen.
So, but if say I had, but if I had HNO3 in my hand, what
Yeah.
would it look like?
What, would you have one molecule of HNO3, or would you have HNO3 all
Not the only one.
The HNO3 all together would be HNO3 bonded together. Because it would look like one H, one N, and 3 O's.
Like in what, like in our
It would be, if that nitric acid results from you dissolving the gas, nitrogen dioxide, and so HNO3 doesn't exist outside of water. But it also doesn't really exist inside of water. That's the problem with me describing this.
okay. No, that's I was just had that in my head. Thank you.
My arm is has the brain of itself.
Is it soluble?
Yeah.
Is this thing going to be highly soluble? Yes, it is. Okay. So you don't have to balance it. I'm not. Did you see any reactions here? Did you see any arrows? We're just listing. It's like saying. It's like saying in my home I have a snake, 2 dogs, and 2 human beings, right? Let's list all the major entities in my home. We have snakes, dogs, and humans. Did I tell you how many snakes? Tell you how many dogs? Tell you how many? No, I'm just listing. We got snakes, we got dogs, we got.
John,
Yes. Those are the major entities. Does the aluminium sulfate stick together?
Whoa, I'm gonna
And what do you mean if it's strong? Strong doesn't mean anything. No strong ion. It's either high soluble. If it's highly soluble, this thing is soluble, so it breaks up. If it's low soluble, if it's insoluble, if it's not soluble, then it will. It's close, okay? But we're just listing what is AL. Yeah, but why didn't you put through?
Oh, this is the garbage.
I understand. In the formula of lose sulfate, there are 3 of them. Yeah. But I don't care how many. Okay, we're just listing
Japanese theory,
like
like
what's in it. Okay. Okay. I wanna make an analogy. I wanna stop some people right now. Okay. I wanna stop some people. The aluminum sulfate one is a really good question for kind of me to talk about. When I say list the major entities, I'm just saying list them off. For example, this is a stupid analogy, but just listen up. You know this is stupid. In my house, okay, I've got me, my wife, 2 dogs. Oh man, this is gonna be ugly. 2 dogs. Okay, times 2. And we've got one snake, right?
Yeah, because you said
Whatever, doesn't matter. Okay? Okay, I want you to list all of the organisms that we have in my house. Let's list them out. Dog. I don't care how many there are. No. We're just listing what organisms exist in my house. Dog. Human. Snake. Right? Do you agree? When you walk into my house, you will probably meet a human, you will probably meet a dog, and God forbidding, you will probably meet a snake, right? As some point in time. Okay? So, now let's try this out. When I put Al2SO4 into water, is it high solubility?
Yes.
Yes, it is. So what does that mean? Is the aluminum and the sulfate, are they stuck together anymore? No, they split up. So what do they turn into? They will split up. Yes, I agree. 2 aluminum ions will split off. I agree. 3 sulfate ions will split off, right? But let's list all the major entities. When you run into this compound in water, what's something you could run into? Aluminum ion. Did I tell you how many aluminum ions there were? When I'm listing the major entities, no. You will run into aluminum ions. Okay. You will run into what else? Sulfate ions.
And H2O.
And you will run into water molecules. I totally agree. I totally agree. When this thing breaks up, you will get 2 aluminums breaking off. You will also get 3 sulfates breaking off. But when I list all the things that you could run into, I'm not going to say 2 aluminums, because I'm not saying you're going to run into 2 aluminums. I'm saying you're going to run into aluminums. You're going to run into sulfates. You're going to run into water molecules. Does that make sense? We're just listing all the things that could be in the solution. Okay? I'm going to give you 3 more minutes to finish this if you haven't already. Yeah, but one ion. This is only
There's all of it.
Yeah, dichromate's not in there, right? Yeah, but what is it?
Don't know that we
Group 1 ion. What is it? So you don't see potassium dichromate?
No, watch out. I might say
Is that okay? I understand we normally talk about the negative ions, right?
yes.
But there are some positive ions up here. Okay, so you can also look for the positive ions.
So it's aqueous.
Yeah. What time is it? What? Yeah, the silver and the chloride, yeah. Low solubility. So it's a solid. It'll stay as a solid, right? Yeah. It'll stay as a solid. Yeah, that's paraffin lime. Okay. And so we're going to talk about that. It's not in here. It's not in yeah. It's like if I talk to you in chemistry. Yeah. Okay. Believe it or not, that was 3 minutes. So let's run through these together, and we're going to do them as fast as possible because I want to give you more practice. Okay? Deal with it. It's all good. Aluminium sulfate, is it ionic, molecular, acidic, or is it it's ionic? Is it high solubility or low solubility? What do you mean you don't know? You just check the table, right? It's high solubility.
Oh, never mind.
There you go. So we're going to have aluminum ions. We're going to have sulfate ions. and we're going to have water. Potassium dichromate. I don't know if anybody noticed, but when you look at your data booklet, okay. When you look at your data booklet, dichromate's not in here, is it? Cr2O7. But what is in here? Group 1 ions. All group 1 ions are soluble except for cesium perchlorate. Doesn't matter. So all group 1 ions are always soluble. If it's a group 1 ion, it's always soluble. Okay? So potassium dichromate, yeah, it'll split up. Absolutely, it'll split up. So we're going to have potassium ions. We're going to have dichromate ions, Cr2O7 2 minus. And we're going to have water. Okay, acetic acid. Is it going to split up?
No.
No, it's a weak acid. So CH3COOH aqueous. And we're going to get water. Sulfur. What is it? It's an element, right? So it's just going to be S8 and solid. Plus water. Copper 2 sulfate. Is copper 2 sulfate high or low solubility? Kylan, you doing okay? Morgan, you doing okay? Okay, I'm asking some questions right now. Is it okay if you stop talking? Okay. Copper 2 sulfate, is it high solubility or low solubility? High solubility. So we got copper 2 plus and SO4 2 minus and water. Silver chloride. It's ionic. Is it high solubility or low solubility? It's low solubility. So silver chloride stays as a solid, and we have H2O floating around it. And then paraffin wax. Is it an all? Is it one of the alls that you had to memorize? No, it's not one of those alls. It's not a sugar. It's not a something. So it's going to stay as solid. Besides, when's the last time you put a candle in water? Did the candle suddenly disappear? No. Okay, so it's going to be C25H52 solid and water. We are done. We are done our 5.2 section. We're not going to go into that. The rest of that stuff is I'm not going to say optional, but it's something that we'll cover later on in the semester, okay?